Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Today we learn what is called futures. See, the possible, only three things are possible or three questions are possible in this particular chapter. One is different kinds of futures, feature transformations, and construction and selection of features. Only three questions. Right, before going to, what is exactly feature? Feature is nothing but an attribute, right? The headings of column names. These are called features. 1, 2, 3, 4, 5. There are 5 features. Feature means an attribute, right? Common feature domains include real, this is called domain. The common feature domains include real integer numbers, but also discrete sets such as colors, booleans, and so on. Sets, colors, something like this. Set of colors, green, yellow, VBG, or something like that. That set also it may contain boolean, true or false. We can also distinguish feature by the range of permissible operations. What are the operations that can be performed on a feature? Some future features, so we cannot operate. Plus, suppose, for example, you take addition or summation. Summation cannot be done on door numbers. My dear friends, on door numbers, you cannot perform summation. Similarly, on ranking, suppose if there is a rank, you cannot perform normally. No, you cannot perform summation. Similarly, right, suppose for example, there is a mark M1, M2, M3, something like that. You can add these three, getting sum. No, on some features, you can do average age, no, like with a summation age, whatever. See, for example, we can calculate a group of people's average age, but not their average blood type. So taking average value is an operation that is permissible only on some features, but not all. So this is what it is, right? Different kinds of features we have. See, this is all general information, but as examination point of view, you are having only three things. One is different kinds of features, feature transformations, and feature construction and selection. Let us go one by one. Right, some operations are not meaningful on some features. Again, averaging on door number, something like this. Right, types of operations performed on features. This is very important. What are the different types of operations that are performed on any feature? Possible operations. One is called statistical central tendency. Statistical central tendency, dispersion, and shape statistics. There are only three things. One is central tendency, generally called as mean, mode, mean, median. These three come under central tendency. Dispersion, variance, and standard deviation. And shape means histogram or skewness. So the histogram, they all come under shape of statistics. Right. Let us go one by one. What is called statistics of central tendency, mean or average. Mean or average. In order to calculate the mean, we need a feature expressed on some linear scale. Mean is more sensitive to other outliers. In most cases, median is preferred. The mean means, for example, if you have a points like this. No, for example, okay. if I have values here, one value, one value, one value, and another value is very far. Because of this farthest value, the mean gets changed. The mean gets changed. No, many points are at one place, what one or two points are at the farthest place. Automatically mean gets changed. For example, you take what is the average of 1, 2, 3, 4 and 40. What is the average of this? 1, 2, 3, 4, 3 plus 3, 6 plus 4, 10 plus 40, 50 by 1, 2, 3, 4, 5. 50 by 5, it gives you 10. Whereas if there is no 40 here, 1, 2, 3, 4, what is the average of this? 10 by 4, it gives you 2.5. Whereas 2, because of 1 point, my dear friends, because of 1 point, the mean is distracted like anything. See, normally if we omit this outlier or farthest point, we can get only 2.5, whereas if you consider that, we'll get 10. That's why in most cases median is preferred. Let us see what do you mean by median and all. Now mode, which is the middle value. How do you calculate middle value? If there are odd number 1, 2, 3, 4, 5, then we say 3 is called mode. Suppose if you have 1, 2, 3, 4, 5, 6, then the average of 3, 4, the average of 3, 4 is called mode sometimes. So something like this. This is called mode. The median tends to fall 1/3 of the way from mean to mode. 1/3 way. This is also called thumb rule. Median, which is the majority, To calculate the median, we need to have an ordering of future values, an ordering, some linear order, 1, 2, 3, 4, or 4, 5, 4, 3, 2, 1. Some ordering is required. So these are all some operations that can be performed on any feature. These are called central tendency. Central tendency. Now, dispersion statistics. Let us see. Now, operations performed on can be divided into 3 parts. And the statistics, central tendency, mean, mode, median, mid-range point, all these come under central tendency. Similarly, if you talk about dispersion, variance, standard deviation, range, percentile, all these come under dispersion. Shape, skewness, kurtosis. So these two come under shape of statistics. What do you mean by mean? We know mean, we know how to calculate mode, we know how to calculate even median. Mid-range point, minimum plus maximum by 2 is called mid-range point. As simple as this. Now, what do you mean by variance? What do you mean by standard deviation? Normally, variance is called the difference between the variance between mean. The variance to mean is called variance. So it is represented normally with a sigma, something like this. Now, variance. Square root of the variance is called standard deviation. Normally, variance and standard deviation show the same thing, but a very small difference. Let me explain the variance and the standard deviation. Right. Variance means the average squared deviation of values from mean. For example, if you calculate 1, 2, 3, 4, 5, 6. What is the average of this? What is the mean of this? 1 plus 2, 3, 3 plus 3, 6, 10, 15, 21. 21 by 6 is called the mean. That is approximately 3.5. Now, what is the difference between average deviations? 1 minus 3.5, 2 minus 3.5, 3 minus 3.5, 4 minus 3.5, 5 minus 3.5, 6 minus 3.5. You call these are variation. What is the average variation? Average deviation. The average deviation. Average deviation is called variance. Is called variance. Normally said to be S square, something like this. Variance. And what is called standard deviation? Square root of this variance is called, square root of this is called standard deviation. Remember, my dear friends, these are mainly used, these are all also called as unit independent. Units independent. If we go for standard deviation, it is also called as units independent. Ante, for example, if you take kilometers, now kilometers lo 1000 kilometers, lapate meters తీసుకున్నారు అనుకోండి. If you take meters, we call it as 1000 meters, 2000 meters, 3000 meters, or 5000 meters అంటాం. అదే if you take kilometers, we say 1 kilometer, 2 kilometer, 3 kilometer, 5 kilometer. If you take the average of this, 1 plus 2, 3 plus 3, 6 plus 5, 11 అంటాం. So we say here it is 11 by 4 అంటాం. So we'll get 11 by 4 as maybe 10 అంటే 2.75 something like that. Okay. If you take this 1000, 2000, 3000, 3000, 6000 and 11,000 by 4, it gives you something like that, 275, 2750. No, it is 2.75, it is 2750, but it is kilometers, it is meters. But if you take variance, so 1 minus 2.75, 2 minus 2.75, 3 minus 2.75, and 4 minus 2.75. Similarly, here we'll be taking 2750 and 2750. And if you calculate the standard deviation for these two measures, standard deviation would be the same. That is the purpose of standard deviation. Hope you understand standard deviation. Right. Now, what do you mean by percentile? Let us see. Variance, we talked about variance, we talked about standard deviation. Range, I need not tell you range, because range means minimum to maximum is called range. Now, percentile, what do you mean by percentile? Let me explain what do you mean by percentile. Percentile means if the domain is divided into 100 parts. 100 parts. The first part, the 0th part contains, first part, it is called 0th part, contains, they are all linearly scaled, my dear friends. Linearly scaled means linearly ordered. For example, if you have 300 values, no, for each, no, I'll put 3 here, that is 3. If I place 3 here, what is the meaning? No, values which are less than 3 will be in 0th one. Values less than 6 will be in first one. Something like this. See, this is called percentile, my dear friends, percentiles. The pth percentile is the value such that p% of instances fall below it. For example, if I say 5 values are below this percentile. Similarly, if you have 100 instances, the 80th percentile is the value of 81st instance. Of course, in a list of increasing values. If p is a multiple of 25, that percentile is called quartiles. Just No, terminology and terminology, just terminology. Quartile. Similarly, if it is a multiple of 10, we call it as deciles. 50th percentile anna, 50th and half. 5th decile anna, 50th. 5 into 10 kada. And second quartile anna, 50th. Same as median. 1 by 2 kada. Median anna kuda ante kada. 1 by 2. Median kada. So this is called, no. Percentiles, deciles and quartiles are special cases of quantiles. What is called quantiles. Once we have quantiles, we can measure dispersion as the distance between different quantiles. Now, for instance, interquartile range is the difference between third and first quartile, 75th and 25th. So something like these are all called terminology of percentage. Right. Now, what is some more terminology? Harmonic mean. Harmonic mean is h of x comma y is equal to 2xy by x plus 1. Similarly, geometric mean, g of x comma y is equal to root of xy. Cumulative probability distribution. We will come to know this. Cumulative probability distribution. Now, what do you mean by histogram? Histogram means bar charts. It appears like this. This is called histogram. Histogram. Right, anyhow, we will be learning all these things, but you should know the meaning, terminology. What is called central moment of a sample? Central moment of a sample. In general, kth central moment of a sample, x1, x2, x3, xn is defined as mk is equal to 1 by n into sigma 1 to n xi minus mu whole power k, where mu is the sample mean. Sample mean. So we talked about this. See that means, see, 1 minus, what is the mean? 1, 2, 3 plus 3, 6 plus 4, 10, 15, 21, 3.5. 1 minus 3.5 whole power whole square k. If you talk about m2, m1, then we'll say it is 1 minus 3.5 whole power 1 plus 2 minus 3.5, 3 minus 3.5, 4 minus 4.5, 5 minus 3.5. If you talk about m2, that would be 1 minus 3.5 whole square plus 2 minus 3.5 whole square, something like this. And these are all must be divided by n. This is called central moment. M1 is 0. M1 is 0. Because M1 enduku 0? Children. Because M1 would be definitely 0. Because this becomes 0, my dear friends. Right. M2 is equal to squared deviation from the mean known as variance. M2 would be variance. M1 is 0. M2 is called variance. Variance under. The third central moment, M3, can be positive or negative. Skewness is then defined as M3 by rho 3, rho cube, where rho is sample standard deviation. M3 by rho cube is called skewness. M3 by rho cube is called skewness. What do you mean by M3, my dear friends? M3 is equal to sigma xi minus mean whole cube by m is called M3, and by rho 3 is called skewness. A positive value of skewness means that the distribution is right skewed, which means that right tail is longer than the left tail. Right tail is longer than the left tail. Right tail is longer than the left tail. Negative skewness indicates opposite. Left is longer than right. So this is called skewness. Similarly, curtious is defined as M4 by standard rho power 4. As it is shown that a normal distribution has curtices as 3. People often use excess curtis M4 minus 3 as statistics of nearest interest. Briefly, positive excess curtis means that the distribution is more sharply peak than the normal distribution. These are all the inferences, right? Anyhow, this is called skewness. This is called curtis. Okay, right. Let us go back. What we learned here, my dear friends, we learned what is called mean, mode, median, mid-range point, variance, standard deviation, range, percentile, skewness, and curtices. Hope you understood all operations on features. These are all the operations on features. Next, coming to the what is called kinds of features. Feature kinds. This is what we were talking about. See, now we came to the first one, different kinds of features. Now, there are 3 types of features: quantitative or continuous, ordinal, and categorical. There are only 3 features, my dear friend: quantitative or continuous, ordinal, and categorical. See, features with numerical scale are called as continuous or quantitative. All statistic measures can be applied, like mean, mode, median, standard deviation, variance, all can be applied. The such type of features are called quantitative features or continuous features. Ordinal, what do you mean by ordinal? Features with ordering but without scale are said to be ordinal. See, you cannot calculate, you cannot calculate mean. Mean cannot be calculated. Such cannot be calculated. Such features are called ordinal features, where mode can be calculated as well as median also can be calculated, but mean cannot be calculated. Such features are called ordinal features. Similarly, categorical features. What are meant by categorical features? Features without ordering. There won't be any order. Ordering undadu. And scale also not possible. Not possible. See, for example, gender. You take gender. F, M. There is no order. Which comes first? Which comes next? You cannot order. No. You cannot. No. So these such type of features are called categorical. They do not allow any statistical summary except mode. Mode can be applied, but mean, median, or standard deviation, variance you cannot apply. But one subspecies of categorical feature is Boolean feature. Boolean categorical. Boolean means which maps into the truth values true or false. True or false. Such one is called Boolean categorical feature. Boolean categorical feature. There are only 3 kinds of features. One is quantitative or continuous, ordinal, and categorical features. Now, you can see the main difference between all these 3 is categorical. Categorical, see, you can see here, they are not, they cannot have any order. Order undadu. No order, no scaling. Only mode okkate cheyagalavu. Ante enni saarlu vachindi. Atla repetition, how many times it is repeated. Anedi maatrame you can count. That is called mode. And not applicable. Dispersion not applicable. As well as shape is also we cannot. So such type of features are called as categorical. The properties of categorical are these. Now coming to the ordinal, all categorical properties apply for ordinal as well as quantitative. For example, Ordinal has order. Order undi. For example, you take door number 1, 2, 3, 4. Order is there. So you can say definitely 1 comes first, and then after that only 2 comes. But you cannot say the difference. No, you cannot measure the difference between 1 key, 2 key majhilo enta difference undi, 2 key, 3 key majhilo enta difference undi. Avi rendu equal? No, we cannot say that. We can only just order cheyagalam. Such one is called ordinal. Here mode can be used, median also can be used. Median also can be used. Quantiles are also there. Quantiles means, remember my dear friends, quantiles means for 25. All 25th, 25, 50, 75, 100 are called quantiles. Quantitative, on the other hand, you can see this is an order. There is a scale. You can calculate mean, median, mode, and range, interquantile range, variance, standard deviation. Ivanni apply chesukochu. And then skewness, kurtosis. All these can be applied. These are all the, when you ask a question like different kinds of features, you have to write there are 3 features. One is quantitative, ordinal, categorical. So categorical ante enti, mean, mode and apply cheyadam etla, ivanni kuda rayalsi. Okay, hope you understand. Now ordinal and quantitative features, on the other hand, gives rise to a binary split. Ante binary split by selecting a v0 select chestunnav anko, such that all instances with feature values less than, ivanni kuda less than v0, ivanni kuda greater than or equal to v0. So this is v1, this is v2, where v1 all elements having less than v0, all elements having greater than or equal to v0. Alanti situation cheppagalam. See, we such that all instances with feature value less than or equal to v0 go to one child and the remaining instance to the other child. It follows that tree models are insensitive to the scale of quantitative feature. See, quantitative features ki insensitive anta. Okay, hope you understood, right? This is, now what do you mean by structured feature, right? So we talked about categorical feature, ordinal, quantitative, and then we have seen the special quality of ordinal or quantitative feature. How can we build a tree? Now structured feature. It is usually assumed that an instance of a vector instance is a vector of feature values. Vector means an array of another. In other words, the instance space is a Cartesian product of D features domain, that is equal to x is equal to f1 into f2 into fd. This means that there is no other information available about an instance apart from the information conveyed by its feature values. Right, structured features that operate on such structured instance space are called as structured features. Ilanti Cartesian product lekapothe sometimes it is necessary to avoid such abstraction. For example, identifying an instance with a okay, abstraction, filtering, say unnecessary information anta filter chesesin tarvata ala some, for example, we could represent an email as long string or as a sequence of words or punctuation marks or as a tree that captures HTML markup. See, some structured instance, this is called structured instance space. Features that operate on such structured instance spaces are called as structured features. Hope you understood. We completed feature, different kinds of features. Different kinds of features. We talked about, this is Right. Next one is feature transformations.